All right, I'm going to talk to you a little bit about a piece of software developed by MITRE called Cogulator. It's open source and freely available. Cogulator is a cognitive calculator. So what the heck is that? Well, Wikipedia has a decent definition of that. It's a method of quantifying human behavior and cognition used by designers to create optimal user experience and interaction. That still may be a little bit fuzzy. Let's take a look and see how Cogulator works. All right. So in Cogulator, what you're going to do is take a series of task steps. You feed those into Cogulator, and then Cogulator will spit out two things. One, task time, and the other, mental difficulty. Task time is just how long it takes to complete some task, and mental difficulty is the amount of workload imposed on the user by your interface. Cogulator is built on GOMS, goals, operators, methods, and selection rules. And like GOMS, Cogulator has two kind of basic assumptions. One, what you're trying to model is a task that involves some sort of interface. And number two, your user is familiar with that interface. All right, so what kind of things can you model with Cogulator? Let me give you a couple quick examples. First, imagine you're building a travel website where people go and book flights. You're not exactly sure how it's going to work yet. You want it to be efficient so people can move through the website quickly and book the tickets. And you've got a couple of different ideas of how that might go. Let's say you have three different options. Well, one thing you could do with Cogulator is before you ever build the website, model how a user would use it. So you just list the steps. Okay, in option A, first you're going to go to this button, and then this button, and then this button, and you're going to read this, and then go to this link, etc., etc. B is something slightly different, and C, whatever. So you've got three different options. You model them all in Cogulator, and Cogulator will let you know which one of those options is the most efficient way of going. Now, efficiency isn't the only way you decide what interface to go with, but it's a good metric among other good metrics. Another thing you could model outside of the kind of thing you do with a website is interaction with an iPhone, or you could model interaction with hardware interfaces, things like a pilot flying an aircraft. So I could model a pilot setting the flaps, and if I was a designer for a flight deck, I could say, okay, well, somebody's had the idea to change the flap lever from a lever that you reach out and grab to a touchscreen interface with the button that you push. And I could say, okay, which one of these is quicker? And if I were to build that model, I'd find the lever is actually quicker because I don't have to look at it before I grab it. I know where it is in space and it has a unique feel. That's not true with the touchscreen. I need to look at the touchscreen first and then touch the target. I'd probably also find that because I can keep my eyes up and out the window, that the lever imposes a little bit less mental workload than the touchscreen interface, although it probably wouldn't be a significant difference. All right, so those are the sort of things you can do with Cogulator. I think it's probably way past time. Let's open up Cogulator and build a few example models. All right, so let's look at building a model in Cogulator. To start, let's press the New button. And I'm just going to make up a name for this model, my first model, and press the Enter key. So we're greeted with a blank page. So remember I said that what we wanted to do to build a model was describe each step necessary to accomplish the task. Well, to describe each step, we use something called an operator. We'll use one operator in each step. And the operators are basically keywords that describe human actions. There's a whole list of them that are provided with Cogulator by default. Let's start by building a model of somebody pointing and clicking to something on the screen. I'm going to say it's this New button, but it could be anything on the computer screen that you would point to and click with, point and click to. So let's look for some keywords here that describe what it is we're trying to do. Well, if I go to the bottom, I see point. And that sounds good. Let me hit the info button, move cursor via the mouse. Well, that's exactly what we're talking about. It takes 950 milliseconds on average. I mentioned some folks will do this quicker, some folks will do it slower, but on average, the average person will take about 950 milliseconds. So I'm going to click point, and then I look at the click button, same kind of thing, press of a mouse button. Okay, again, that sounds about right to me. I'm going to click the click button, as it were. Now I've got a task that takes 1.3 seconds. But Cogulator's got this little orange hint button up here. So let's see what that's about. It's saying add a look before the point. So before I can point and click on a button, whether it be this New button or any other button on the screen, I need to look at it. and Cogulator's suggesting that I add that to my model. And that seems like a good idea. So I'm going to click Add. And now I've got a perfectly valid model, 1.8 seconds, with just 3 keywords: look, point, click. And that's all it takes to build a valid model in Cogulator. If I go down to the Gantt chart at the bottom, I can see what the task is composed of: 550 milliseconds for look, 950 for point, 320 for click. All Cogulator does is look at those keywords and their operator times and adds them up in order to get you a task time. It gets a little bit more complicated when you do multitasking, but we'll talk about that in a separate video. In addition, we'll talk about some of this stuff at the bottom in a separate video, including the average working memory chunks. That'll be in the mental workload or mental difficulty video. All right, so I've got a model, look, point, and click. Now, if I want to, I can add some description. Look at the new button, point to the new button, click on the new button. All right, these words can be anything I want them to be. I chose these words. They just add context so that when I come back and look at this model later, I'll have some idea what's going on. Now, there are 3 exceptions to that: the type operator, the say operator, and the here operator. If I do type hello, hit reload, notice now my task time goes 3.2 seconds. If I do type hello world, it goes at a 4.9. So in type, say, and here, Cogulator is looking at what's in the string, and it could be anything you want it to be, but whatever it's in there, Cogulator looks and says, okay, well, how many characters do I need to type in order to type hello world? And it makes an adjustment for the prediction based on that amount of characters. All right. Last thing I want to look at is goal statements. I'm just going to type goal, point, and click, and add a period before each of these. Essentially what I'm doing is creating a bulleted list. Notice my task time is still exactly the same, 1.8 seconds. But this just allows me to organize the model again, and this is super useful if I have lots of goals that are composed of that compose a larger task. Okay, last thing I just want to mention here on the left side is some of the example models. There's kind of simple models in KLM, same basic model but with some goal structure in Ngomsl, and a very detailed version of the same model in CPM GOMS. Probably most importantly, though, is this sundry methods. This is just random different things you may want to try and model in Cogulator: pointing and clicking, typing something, swiping through a list on an iPhone, listening to a lecture. In this case, we're listening and taking notes at the same time, so we have multitasking, setting a car handbrake. So just kind of random stuff that may be useful as references if you're building models in Cogulator. And now we're going to do 2 other videos. One will be on multitasking, so you'll see how that's done. And the other video will be on mental workload, and it'll describe how we use the chunk naming feature to estimate mental workload or mental difficulty of a task. And that's it. Thanks a lot.